This video is for worked example 7 of the topic Atoms, Molecules and Stoichiometry in H1 and H2 Chemistry. If you were to look at the general equation at the top of the screen, this general equation shows the combustion of a gaseous hydrocarbon. Now you do not need to memorize these coefficients if you know how to balance the equation using the method given in the notes. Now this general equation is limited to hydrocarbons, so can the equation be applied to oxygen-containing organic compounds, meaning organic compounds that contain carbon, hydrogen as well as oxygen? Well, we can't use the general equation, but we do not need to memorize the general equation anyway. So let's take a look at worked example 7. Apart from hydrocarbons, the complete combustion of other organic compounds, shown below, can also produce carbon dioxide and water. Which of the following compounds requires 4 moles of oxygen molecules for the complete combustion of 1 mole of the compound? So let's take a look at this question more closely. I'm going to work this through with you. These 4 compounds are all organic compounds that contain oxygen. Now, when they burn in oxygen or when they combust in excess oxygen, they all produce carbon dioxide and water. So just give me a while to try to write out all the balanced equations. Carbon dioxide and water. Now I'm going to balance them one by one, and it's a lot easier than you think if you know which sequence to balance them. So let's take a look at option A. Option A, now the first thing you should do is to always balance the carbon first. So on the left you have 2 carbons, so on the right means you're going to have 2 carbon dioxide. Next, balance the hydrogens. 3 plus 1, that's 4. 4 hydrogens means over here I need 2, because 2 times 2 is 4. So now I look at the oxygens on the right hand side because the carbons and hydrogens are balanced already. So the oxygen would be 2 times 2, that's 4, plus another 2, that's 6 oxygens on the right. On the left there's already 1 here, so I just need another 5 over 2 moles of oxygen gas. This is a balanced equation. Notice in all situations my hydrocarbons will always be a stoichiometry ratio of 1, and it is okay to have fractions in the balanced equation. So if I use the same method for option B, C and D, you'll see what happens. For option B, there are 2 carbons from the left, so 2 carbon dioxide, 3, 4, 5, 6 hydrogens, so that's 3 over here. So 2 times 2 is 4, 5, 6, 7. 7 oxygens on the right, minus 1, that's 6, so it's 3 moles of oxygen gas. For option C, 1, 2, 3. 3 carbons on the right, so 3 moles of carbon dioxide. 3 plus 3, 6 moles of hydrogen gas, so that's 3 over here. So 2 times 3 is 6, 7, 8, 9. 9 oxygens on the right, minus 1 is 8. There we have it. This is the answer because the question wants 4 moles of oxygen. But let's balance the last one anyway. 1, 2, 3 carbons over here. 3, 4, 5, 6, 7, 8. And 2 times 3 is 6. Plus another 4 is 10. Minus 1 is 9. And there you have it. All 4 equations are balanced. Not hydrocarbons. The organic compounds always a ratio of 1, and fractions are accepted.